Okay, let's now look at finding a percentage and expressing as a percentage. Two really useful things to know. What we want to be able to do by the end of today's lesson is we want to be able to express one quantity as a percentage of another, and we want to be able to find a certain percentage of a quantity. Now that might seem like it doesn't make sense yet, but you'll see what we're talking about. So the first one, let's look at expressing one quantity as a percentage of another. This is just how you calculate your percentages for tests. You remember that I told you, my students at the start of the year, that I would teach you how to calculate the percentages on your tests once? I told a fib. I'm going to teach it to you at least 2 times. So, in order to do this, we want to write a fraction with the part amount as the numerator and the whole amount as the denominator. So for example, on a test, if you got 45 out of 60, you would write 45 as the numerator divided by 60, the denominator. Then, as we looked at in our previous lesson, to convert from a fraction to a percentage, we need to multiply by 100. So this skill is really stuff that you've done before. We're just marrying things together. So like we said, this follows pretty much the same process we used when converting a fraction to a percentage previously. So let's look at some examples. It says express the following. I said express twice. Express the first quantity as a percentage of the second. So when it says that, 20 out of 80, when we say out of, we really mean 20 divided by 80. Now that's lovely, but to express this as a percentage, we currently have a fraction. We want to multiply it by 100. Now when we're multiplying a fraction with a number, ideally we want to have a fraction times a fraction because we can cancel things down. So like we've been doing previously, we could write that as over 1. Okay, I always prefer to cancel before we continue. So 20 goes into itself once and it goes into 80 4 times. But we can also cancel in this direction. 4 goes into 4 once, and it goes into 125 times. So what are we left with? This first fraction has become 1 over 1. So 1 times 25 for the numerator becomes 25, and then 1 times 1 for the denominator, like we spoke about in the past. Whole number divided by 1 is the number you started with. So that would be 25, and we're expressing this as a percentage, so percent. Again, if you're the kind of person who'll forget that, make sure you underline or highlight it in the question. Let's have a look at some more. 60 out of 240 could be written as 60 divided by 240. And to go from a fraction to a percentage, we're going to multiply by 100, and we said let's do that over 1. Let's cancel off what we can. So I know that we could cancel both of these, dividing them by 10. I see that 6 goes into both of these numbers, so 6 goes into 24 4 times, and it goes into 60 10 times. Oh, I can cancel that down even further. 4 goes into, 4 and 10, the highest common factor will be 2. So 2 goes into 4 twice, I nearly forgot for a second there, and 2 goes into 10 5 times. So let's clean that up a little bit. We're left with 5 over 2 times 10 over 1. You might find it useful to rewrite what you have left and really check that you're doing this correctly. So we're going to have 50 divided by 2. Oh, now we can actually just halve that. That's what dividing by 2 means. So half of 50 is 25. And we need to write percent. Very nice. And that makes sense. If we look at 60 and 240, if I did 60 times 4, that gives me 240. So it makes sense that 60 is 25% or a quarter of 240. Let's continue. So we're going to have 81 divided by 90. Again, times 100 over 1. Cancel down anything you can. I see 9 goes into 81 9 times, and it goes into 90 10 times. That's really nice because we can then say, okay, 10 and 100 now. 10 goes into 10 once and into 100 10 times. What are we left with? Numerators, we've got 9 times 10 to give us 90. On the denominator, 1 times 1, so it would just be over 1. So 90 over 1 is just 90, and we need to put 90%. Now, what's really important is that our units are the same if we've got units. So notice here we've got hours for part D, but then we've got day. And that's not going to work super well. So let's maybe instead of writing 1 day, we could write 24 hours. same unit. You might have converted 16 hours to a decimal of a day or a fraction of a day, but I think it's easier to put them both in hours. So 16 hours over 24 hours, and to convert to a percentage, times 100 over 1. What can we cancel? 4s work nicely. 4 goes into 16 4 times, goes into 24 6 times. Oh, that wasn't the highest common factor, but that's okay. We can put 2 into 4 twice and into 6 3 times. Can't cancel anything off with the remaining fractions, so we've got 2 times 100 on our numerator, then 3 times 1 on our denominator. Okay, that would be fine, but we could write this as actually figuring out what 200 divided by 3 is. So 3 doesn't go into 2, but it goes into 20. We could do 6 times with 2 remainder. 3 goes into 20 again, 6 times with 2 remainder. Pop a decimal point there and there. Oh, we're getting a bit of a pattern. 3 goes into 20 6 times with 2 remainder, 6 times with 2 remainder. I think we're going to be continuing on like this forever. So we could write that as 66.6 recurring percent, or if we didn't do it as a decimal percentage style, if we instead, when we had a remainder before, 200 divided by 3, so we said it was 66, and we got to this point here, and we said we had 2 remainder, so we could have also written that as 2/3. So that could also be written as 66 and 2/3%. Awesome. So I'd like you to have a go at the last two, keeping in mind how we convert monetary amounts and a nice bit of revision in F of how we convert lengths. Pause, have a go at these two and see what you get, and you can check in a moment. Okay, double check whether I've done this correctly. I said that $2 was equal to 200 cents. We do the smaller number 200 divided by 500, and once we cancelled things down and multiplied, we get 40% there. Then for 12 millimeters out of 60 centimeters, I find putting them both into millimeters easier here. So we'd have 12 over 600. Cancelling that down, I got 2%. So see if you get the same thing. Okay, we have 2 students want to compare their percentages on a recent languages test. Georgia did Chinese, and her test result was 56 out of 70. Charlotte did French, and she received 90 out of 125. So they're trying to figure out who received the highest percentage. Remember though, your test results are always private. You don't need to share it with anyone. This is a worked example, and I'm sure Georgia and Charlotte don't mind. Okay, so Georgia's result. She got 56 out of 70. And to be able to convert that to a percentage, we need to multiply by 100 over 1. Remember, we're trying to figure out who received the highest percentage. So converting both of these numbers to percentages allows us to compare them nicely. Okay, can we cancel anything off before we continue? 10 goes into 100 10 times, into 70 7 times. 7 eighths are 56, so I could do 1 and 8 there. So looking across here, we've got 8 times 10 in the numerator, so 80. And on the denominator, we would have 1 times 1. So we could write that as 80 divided by 1, or you could go straight to 80%. Okay, let's see how Charlotte did in comparison. She got 90 out of 125. And to convert to a percentage, again, we multiply by 100, and we'll do that over 1, because we're doing this by hand. On your calculator, you don't need to multiply it by 100 over 1, you can just do 100. Okay, cancelling down what we can. 25 goes into 100 4 times, and it goes into 125 5 times. Can't cancel anything else. No, I take that back. Yes, we can. 5 goes into 5 once. 5 goes into 90. 5 goes into 90 one time. 4 remainder. 4 5s. 18. Aha. So we've now got 18 over 1 times 4 over 1. So let's do those denominators. Oops, let's pop that 18 there. So 18 times 4 will be on the top. I'm going to do that as an algorithm in a moment, and then 1 times 1 on the bottom. 18 times 4. Could use a mental strategy of doubling it, then doubling it again. 4 8's are 32. 1 times 4, 72. So we'll have 72 over 1, which would be 72%. Okay, so we need to answer this worded question with a worded answer, and the question's actually asking who received the highest percentage. So Georgia. received the highest percentage. Oops. Helps if you can spell percentage. Percentage. Brilliant. Okay, so the skill that we just did is how you've been calculating percentages on your tests all year. The small number or the part divided by the larger number or the whole, and you multiplied that fraction times 100. Now this skill is a little bit different. This skill is one that you might find you're using all the time in life, especially when you're grocery shopping or you're trying to hunt around for bargains and you're trying to calculate percentages, particularly mentally, on the fly to compare the prices of things. So there are quite a few methods that you can use for this, and it depends on the numbers you've been given. Sometimes a quick mental strategy is actually faster than doing a proper algorithm. So, some basic percentages that you might find useful. If you're finding 1% of a quantity, 1% is 1/100th, so you could divide that quantity by 100. Finding 10% of a quantity, that's 10 over 100, or 1/10. So you could divide a quantity by 10 to quickly mentally figure out what 10% of something is. 20% of something is 1/5, so we could divide something by 5 to figure out how big 1/5 of it would be. And 50% of a quantity, that's the same as dividing something by 2. So they might be some percentages that you're relatively familiar with, and we can use nice mental strategies there. So let's see, can we find 35% of 60 in 3 different ways? This isn't just finding the answer, or the ability to find the answer, I should say. This is being able to find that answer in 3 different ways. Okay, so 35% of 60. This is the exciting thing in maths, where we have multiple ways of doing this, and you might actually have a preferred way. So let's look at these 3 different ways, and you might say, hey, I actually like this way the most. So 35% of 60. We could, method 1, 35% of 60. 35%, we said that means 35 over 100. So we could make that percentage into a fraction just by dividing by 100 like that. We'll look at cancelling things down later, but we'll leave it as that for now. Now, of in maths frequently means times. So we're going to put a times sign there. And if we're doing 35 over 100 times 60, we like to multiply fractions with fractions. So let's write that as 60 over 1. Okay, let's now see if we can cancel things down. 10 goes into 60 and 100 like that. Oh, and 5 also works in this direction. 5 goes into 10 twice, goes into 35 7 times. Could also cancel in this direction. 2 goes into 2 once and into 6 3 times. Okay, so on the numerator we're left with 7 times 3, which would be 21. On the denominator, 1 times 1, which would be 1. And as we've been saying, that would equal 21. Now that's not a percentage. We said find 35% of 60, and that's 21. Imagine if that was a unit, 35% of $60. The answer would be $21, not 21%. So 35% of 60, we get a number at the end, 21. Okay, that's one method. Let's try another method. So 35% of 60, I'm just going to rewrite it so we can look at the question over here. We could also write that as the decimal equivalent. So that would be 0.35 times 60. Now with algorithms, we tend to prefer to do that on the side of our page. So let's maybe do it over here, and we'll leave room for method 3 over here. So leave a bit of room there. You don't need to draw a squiggle if you don't want to. So let's do 60 times 0.35. 5 times 0, 0. 5 times 6 is 30. Remember, don't put a decimal yet. Let's go to the next one. Pop a 0 there. 3 times 0 is 0. 3 times 6 is 18. Okay, adding them up. 0 on this column, 0 here. 8 plus 3, we get 11. And 2 for the last column. Now remember, our answer needs the same number of decimal places as the question. So this question had 2. So that means we need to count here to have 2 decimal places at the end. Oh, look at that. We get 21, regardless of which method we chose there. Okay, so they're the methods that are the fraction style and the decimal style. The last method is doing it a little more mentally. So if we want 35% of 60, we could actually build that from basic percentages. We could have 3 lots of 10%, and we could even do 5%. If we wanted 5% of a quantity, that's the same as dividing something by 20. Or you could take the 10% amount and divide it by 2. So let's maybe try that method. So let's build it up. 10% of 60. We said 10% of something is the same as dividing that value by 10. So that would just be equal to 6. So that means 35% of 60 would be 3 lots of 10% plus 5%. So if 10% of 60 was 6, then 5% of 60 would be half of that, which would be 3. Okay, so 3 lots of that 10%, 3 times that 10% was equal to 6, plus the 5% was equal to 3. 3 times 6 is 18, plus 3. 18 plus 3, 21. So we tried a few different methods here. This one might look a bit more bulky because we're doing our working out written it here. But sometimes these values can actually be quite nice, particularly if you had something like, 45%. You could do 50% minus 5%. There's some cool mental strategies you can use for that. What I'll probably do for the next couple of questions though, for the answers, I'll probably use either method 1 or 2, but you're more than welcome to use method 3 if you find that beneficial. So I'd like you to pause, have a go at these questions here. Keep in mind these have some units. So first one kilogram, second one dollars, and last one centimeters. So our final answers at the end would be something kilograms, something dollars for this one, and something centimeters for the last one. So I want you to try either expressing that percentage as a fraction, option 1, or as a decimal, option 2, or if you prefer, option 3. Pause and have a go at these now. Alrighty, I used a combination of methods 1 and 2 here, but again, you might have liked method 3. Check these answers. I got 85 kilos, $224, and 568 centimeters. If we've got more than 100% of 400 centimeters, we've got to have a number at the end that's larger than that. Double check my answers. Let me know if you got something different or if I made an error. And now an opportunity for some independent working time. Good luck. Let me know if you've got any questions.